Today I am going to solve around 6 integral. 1, 2, 3, 4, 5, 6. 6 integral I will try to solve, and let's see how it works. Okay, it may be substitutions, it may be rationalized, so different methods we can solve. Okay, so first we will try to solve one integral of e raised to x upon 1 plus e raised to 2x dx. Okay, in this integration what we can do is we can we have to substitute by u equals to e raised to x. Why? Because see, e raised to 2x is same as e raised to x the whole square. Okay, e raised to 2x is same as e raised to x the whole square. It means e raised to x plus e raised to x is same as x plus x to x. Okay, e raised to 2x is same as e raised to x the whole square. Okay, now if I put u equals to e raised to x, then du will be e raised to x into dx. Okay, therefore I will be getting this one. Okay, if I put u equals to this, then du will be e raised to x dx. Okay, therefore this integral will be e raised to x dx is what? Become a du upon 1 plus e raised to twice x is what? It will be u the whole square. Okay, this is same as u square. This is same as u square. Now we have integration formula. Remember, integral of 1 upon 1 plus x square dx is same as tan inverse of x. Okay, we have this formula, and so here instead of x we have u. Okay, yeah, by applying this formula, this will be tan inverse u plus c. Okay, where c is constant integrations. What is u? We have to come back again here. U is tan inverse, u is what? E raised to x. Okay, e raised to x plus c. Okay, this is the required answer for integral 1. Okay, now for integral 2, let's see how it works. For integral 2, we have integral e raised to 1 by x upon x square dx. You have to think. Okay, you have to think that if I substitute u equals to, for example, if I put u equals to 1 by x, then what will come? Okay, so you have to think. Okay, it means if I put u equals to 1 by x, then what will be du? Okay, 1 by x is same as x raised to minus 1. Okay, now if I differentiate this with respect to u, du by dx is same as x raised to n. Okay, differentiation d by dx of x raised to n is n into x raised to n minus 1. Okay, now here it will be minus 1 x raised to minus 1 minus 1 is minus 2. It means minus 1 by x square. Okay, therefore du equals to, I can send this is here, minus 1 by x square into dx. Okay, now I am getting dx by x square if I put u equals to 1 by x. Okay, so it has meaning. So you have to think such a way that if you put something, then you should get some benefit over here in this integral. Okay, so minus I can send this side, therefore minus du equals to dx upon x square. Okay, therefore what will come? Dx by x square will become a minus du, and this will be e raised to u. Okay, is same as integral e raised to 1 by x is what? U into, okay, dx upon x square. Okay, dx upon x square is what we have? Minus du. Okay, so into minus du. In minus du, we have minus du equals to dx upon x square. Dx upon x square, whole this become a minus du. So there is nothing over here, nothing we have to write over here. So we can remove this, okay? This into, so I can send this minus outside, minus e raised to u and du, okay? Now integration of e raised to u is same as e raised to u. So therefore integral of e raised to u is e raised to u, e raised to u plus constant integration. This is same as, what we have to substitute, u equals to what? 1 by x. So e raised to 1 by x plus c. This is the required answer for 2. This is for 2, okay? Now for 3, now you have to think, okay? Now we have integral of 1 minus sin x upon 1 plus sin x, okay? Now, if I rationalize, okay, if I rationalize, it means if I rationalize 1 minus sin x, numerator and denominator, okay, I will be getting 1 plus sin x into 1 minus sin x. It means a minus b into a plus b, that is a square minus b square. It means I will be getting 1 minus sin square x. 1 minus sin square is cos square x. So I am getting a single term over here. That single term I can, whatever I am getting in the upper, so I can distribute each and every terms. So it has meaning, okay? Therefore we have to do in that way. So let's try to solve number 3. Number 3 is integral of 1 minus sin x upon 1 plus sin x dx, okay? By rationalizing 1 minus sin x, okay, up and down, 1 minus sin x upon 1 plus sin x into 1 minus sin x upon 1 minus sin x dx. Why I am doing 1 minus sin x instead of 1 plus sin x, okay? Now if I do 1 minus sin x, I will be getting a plus b into a minus b, that is a square minus b square. It means I will be getting 1 minus sin square x, that is cos square x, okay? So if I do 1 plus sin x, numerator and denominator, it will be 1 plus sin x the whole square. It become expand. It become expand. So we want to shrink as much as possible into one single term so that I can divide each and every term by that particular term, okay? Therefore I am dividing numerator and denominator by 1 minus sin x, okay? Now this is same as integral. Here 1 minus sin x into 1 minus sin x is at 1 minus sin x the whole square. It means a minus b the whole square, that is a square minus twice ab plus b square, okay? This become a 1 minus sin x the whole square, okay, upon I am getting a plus b into a minus b, that is a square minus b square. A square is 1 square, 1 square is 1 minus sin square x dx, okay? Now here 1 minus sin square x is, we have a minus b the whole square, that is a square minus twice a b, sin x into 1 is 2 sin x plus b square, okay? Sin square x upon, here 1 minus sin square x is what? Cos square x, okay? Cos square x dx. Now here I didn't put anything, okay? All variables are x, here also x, okay? This is equals to, now x, okay? Now what we can do is, we can divide this cos square x to every terms over here, okay? This is same as 1 minus cos square x, okay? Here I will do somehow shortcut. 1 will be 1 upon cos square x minus 2 upon sine by cos square x. So I'll write down, okay? 1 upon cos square x minus 2 sin x upon cos square x plus sin square x upon cos square x, whole integral dx, okay? Now I will write over here. Now here 1 upon cos square x is what? 1 upon cos is what? sec square x, okay, is equals to integral of, still I didn't do any integration, just I am manipulating inside the, inside the integral, okay. 1 minus cos square is, we have sec square x, okay, sec square x minus, here we have cos minus 2, okay, here we have cos square x, okay, this cos square x means cos x into cos x, here 1 cos x, I can say sin x upon cos x, okay, sin by cos is 10 x into another, I have sin x upon cos, I already taken sin x upon cos x, sin x upon cos x is 10x, and another is 1 by cos x, okay, 1 by cos is sec x, okay. Let me repeat again, otherwise what you can do is, you can cos square, instead of cos x, cos square, you can write double cos x, okay. Here, I can bring this sin by cos 10, 1 by cos sec 2 is over here, okay, plus similarly sin square by cos square is 10 square, okay, 10 square x dx. Now here integral of sec square is, you don't remember, integral of sec square x dx is what, okay, remember d by dx of sin x is cos x, d by dx of cos x is minus sin x, d by dx of 10x is what, sec square x, okay. Now if you differentiate 10x, you are getting sec square x. If you integrate sec square x, you will get what, 10x, okay. Therefore integration of sec square x is what, 10x, okay, that is 10x minus, okay, here dy, we have dy dx of sec x is sec x into 10x, okay. Now if you integrate this, then you will get this, okay. This is same as 2 integral of 10x into sec x is what, sec x, okay, sec x, okay. But up to here integration is over, okay. But here we don't have 10 square, so just write still integral of 10 square x dx, okay. Here, for here you can say some plus constant c, okay. Now in trigonometry we have, what we have is 10 square x plus 1 equals to sec square x. This is trigonometric identity, okay. Therefore 10 square x is sec square x minus 1, okay. Instead of 10 square x, I can write sec square x minus 1, that is 10x minus 2 sec x plus integral of, instead of 10 square x, I can write sec square x minus 1 plus c, okay. Now here 10x into 2 sec x plus, here integration of sec square x over same here, integration of sec square x is 10x, okay. 10 of x minus integral of 1 dx is x, okay, minus x plus c, okay. Here 10x I can add twice 10x minus 2 sec x minus x plus c, okay. This is required answer for 3, okay. 1 minus sin x upon 1 plus sin x, okay. Now let's try to solve number 4, okay. Number 4, we have 1 upon sin x, okay. Now here also we have to use some trigonometric identities, or you can say trigonometric formulas. Sin x, what do we have? Okay. Do you remember sin of 2x is, what is formula for sin of 2x? Sin of 2x is 2 sin x cos x, okay. Now if you can bring that over here, okay, and then instead of 1 we have 1 is what, sin square x plus cos square x, okay. If you can bring that into, let's try to solve this one. 4. 4 is what? Integral of 1 upon sine of x dx. Now we have sine of 2 theta equals to 2 sine theta into cos theta. We have this formula, as well as we have identities of sine square theta plus cos square theta equals to 1. Okay, now if we try to use these two over here, okay, let's try. Okay, now I need 2 theta. Okay, I need twice angle over here. Since I have x, so what? Let's put x equals to twice u. Why? Because I want to bring this sine twice theta. Okay, it become, therefore dx become what? 2 du. Okay, because du by dx is same as 2 into 1. So I am cross multiplying is d equals to twice, dx equals to twice du. Okay. Therefore, this become 1 upon, what is dx? It become a 2 twice du sine of twice, instead of x I have twice u. Okay. Now these two I can send outside because it's the constant 2 du upon sine twice u. Yes, we have this. Okay, sine twice is 2 sine of u into cos u. Okay, now we can consider 1 is over here. Okay, so instead of 1, if I write this, then twice sine square u plus cos square u upon integral 2 sine of u into cos of u du. 2 gets cancelled. Now this I can distribute this upon this plus this upon this. Okay, now this implies 2 gets cancelled. Sine square u upon sine of u cos of u d plus cos square u upon sine of u into cos of u into du. All we are in du because we already substituted x equals to twice u. Okay, so we'll integrate this with respect to u, then we'll come back to x. Okay, now sine square u. Now one sine will go over here. We have sine upon cos. Sine upon cos is what? 10. Okay, here sine upon cos we have 10 of u. Why 10 of u? One sine, this sine square, it means sine square into sine square. One sine will get cancelled with this, and one sine upon cos u. Okay, there will be sine upon cos u is 10u. Okay, plus now similarly, now one cos square u is cos square u is same as cos square u into cos square u. One cos square u will get cancelled with denominator and numerator. So cos upon sine is cot of u du. If you have any problem or anything, you can type into the comment if you have anything. Now this is same as integral of 10u du plus integral of cot of u du. Okay, integral of 10u is what? We have log of say x. This is same as log of sec u plus, and this what we have is, we can, or otherwise I will explain over here. Why integral of this is log of sec u? Okay, because we have integral of 10u into du plus integral of cot u into du. So by formula we have integral of 10u is same as log of sec u plus integral of cot u is same as log of sin u. Okay, now instead of what is u? U is what? Here we already put x equals to twice u. Therefore, x by 2 equals to u. Okay, instead of u, you have to put x by 2. Okay, this same as log of sec of u. U means x upon 2 plus log of sine of what is u? U is x upon 2 plus c. Okay, this is a required answer. Now let's try to solve question number 6. Now 6 is what we have. We have we have sine cube x. Okay, sine cube x is what we can use either sine 3 theta formula. You can bring sine cube theta. Okay, sine cube theta. Otherwise, what you can do is you can break sine cube theta as a sine square theta into sine square theta. Sorry, sine square theta into sine theta, and you can substitute one sine theta. Let's try over here. Okay. Now 6. Okay, last sum. Integral of sine of cube x dx. Okay, sine of, it's wet. Now I'm making dry. Okay, hope it works. Integral of, yes, sine of cube x dx. Okay, now this we can use two ways. Okay, one way is we have sine of 3 theta formula. From there is sine cube theta. You can use that either. Otherwise, I will use another way, which is very simple. Sine cube theta is same as sine square theta, sine square x into sine x dx. It's good. Okay, because 2 plus 1 is 3. Okay, base are required. We can add the indices. Sine cube x is sine square x into sine x. Okay, now if I convert sine square x is what? 1 minus cos square x, because sine square x plus cos square x equals to 1. It means sine square x is 1 minus cos square x. Okay, now instead of sine square, if I write 1 minus cos square x sine x dx. Okay, why I am doing this? Because if I put u equals to cos x this, then I will be getting du equals to differentiation of cos x is what? Minus sine x dx. Okay, this sine x dx I will be getting as a du, and this cos square will be u. Okay, so it has meaning. It implies 1 minus cos square is what? U square. Sin x dx is what? I can send minus over here. Okay, this minus over here. It is minus du. Okay. It implies is equals to integral of this. If I integrate this, integral of 1 du minus integral of u square du is same as minus, is here integral 1 du is u minus, this is u cube upon 3. Okay, plus c. What is u? You come back. Okay, what is u? U is what? Cos x. Okay, here cos x minus cos, here u cube is cos cube x upon 3 plus c. Okay, you can send this minus inside. Here we have cos x minus minus plus cos cube x upon 3 cos cube x upon 3 plus c. This is the required answer for this. Okay, so I already solved. There are six questions for integrations. Hope it helps. Thank you.